The demand for remote sports coaching arises when coaches and athletes face geographical constraints or busy schedules. In conventional scenarios, athletes often record videos of their performances or engage in virtual meetings with platforms like FaceTime or Zoom to connect with their coaches. However, these traditional methods mainly rely on 2D video formats, presenting limitations in terms of spatial information and interactive engagement. Integrating VR/AR technologies not only addresses these limitations, but also create new possibilities. VR provides a three-dimensional and spatially accurate representation of the training environment. This helps athletes and coaches better understand the spatial dynamics of the movements. Besides, VR can provide advanced annotation and visualization tools. These tools contribute to a more comprehensive understanding of the performance, allowing coaches to offer a more precise and insightful feedback. This demo presents Augmented Coach, an immersive remote sports training tool with annotation and visualization tools. The system consists of two setups. The first setup is a motion capture area comprising 4 Microsoft Azure Connects. These connects are strategically positioned at the 4 corners of the space, measuring 134 inches by 134 inches. They are synchronized and all connected to a Windows computer. The connects are used to capture volumetric data from the athlete standing at the center of the space performing athletic movements. Once obtained, these volumetric video files are stored on the computer, which is also connected to a MetaQuest 2 device, the hardware used to run the Augmented Coach application. Now let's walk through the user experience of the application running on MetaQuest 2. When the application is loaded, the users will see a welcome page with a virtual basketball court. The users need to choose whether to use the application as a coach or athlete. Then the user will see a calendar with some meeting schedules. When clicking Join, the door of the basketball court will open, and the user's view will be taken to the center of the court. Then the user will see a point cloud model rendered from the volumetric data captured from the athlete and a series of UI elements. We provide playback controls such as play and pause. We also provide immersive analysis tools for them to interact with the athlete's point cloud. To help coaches gain insights into the movement patterns, we provide 3 visualizations. The first one is allowing users to unpack and repack the past to present frames. The Unpack Frames features enables the coach to break down a frame sequence by specifying a number of steps to display and the length of the playback. The second one is letting the users highlight joints of the skeleton visualization on the top of the Repack/Unpack frames, so that the coach can visualize the trajectory or path that a certain body segment, consisting of 1 or more joints, follows during a movement. This helps visualize the trajectory of limbs and skeletal alignment, which are important for the analysis of the athlete's form. The third one is planes of motion, referring to different anatomical planes along which movement can occur in the human body. These planes are spatial divisions used to describe and analyze the directions of movement and range of motion in various joints and body segments. The 3 primary planes of motions are the sagittal plane, frontal plane, and the transverse plane. By visualizing the planes of motion, the coach can observe weight transfer and body movement. The planes are generated based on skeleton-based human body detection. Each plane is generated at the center of the bounding box of the detected human body, and the direction is aligned with the body's orientation. Coaches can choose to apply either the sagittal plane, the frontal plane, or the transverse plane. Thank you for listening, and I can't wait to show you the demo.